We are going to talk about what's called completing the square or complete the square. We are currently in our packet on page 39. That page number might not be in yours. So let me tell you about this figure over here, just because I'm sure you're probably wondering what the heck this is. So these are a circle, an ellipse, a parabola, and a hyperbola are called conic sections. And the reason is because if you take a cone and depending on how you slice it, it will come up to be these different things. So we're talking about the parabola once again. Okay, we won't talk about the other one, so I'm not sure why that picture is there. I'm using somebody else's notes, which are awesome. Okay, to solve quadratics that cannot be factored, we can complete the square of an equation. It is an option to the quadratic formula. So we have learned how to solve by factoring. We've learned how to solve by square roots, and those are very specialized. You have to have that they can be factored or that you can get a squared term by itself. The other form we learned was quadratic formula, which is awesome and most recommended. So, but this is the other way you can do it. You can also use completing the square if complete the square for equations that can be factored. To help, we will identify 3 based on the trinomial 1x squared plus bx plus c. We're not going to do this bottom one. I think it's great, but I think it's kind of a waste. I'll show you what it is, but I won't use it. We are only going to deal with it if a is 1. If a is not 1, it's a whole other ball game, and that's for an Algebra 2 class. Okay, so this goes through the steps right over here as to what you're supposed to do. So nothing hidden there. If I have x squared plus 6x plus 1 equals 0. So we need to move the constant to the other side. So we subtract 1 from both sides. Okay? And note that a has to be 1. And everything we're going to do this year, a has to be 1. Now we're going to identify b, half of b, and half of b squared. So b is 6, just like always. Half of b is 3. Then half of b squared is 9, which is true. I'm going to stop right here, usually when I do it. But for this one, we're going to go all the way through. So we put, and then what we do is we add b, half of b to both sides. Okay? So we're going to add that to both sides, because whatever I do to one side, I have to do to the other side. Therefore, I will not change the equation. Then I'm going to simplify what I have. This side I'm going to leave alone. I have negative 1 plus 9. That gives me 8. And so we have x squared plus 6x plus 9 equals 8. Now what we're going to do is we're going to factor this, but we don't really factor it, okay, because it's a perfect square trinomial. We're going to take the square root of the first and the square root of the last. And the way you'll see me write it is it will be x squared plus 6x plus 3 squared and is equal to negative 1 plus 9. I square it here, but I don't here. The reason is because I'm going to go and take the square root of it. X plus 3 quantity squared. So y squared if I'm just going to take the square root of it. Okay? Then the reason we do it is we go back to what we know about squares. If I get a square term on a side by itself, I can take the square root of both sides. Okay? This is wrong. That should just be 8. Okay? And that should just be 8. Okay? So that's an error. Then we're going to take the square root. I have a square term all by itself, so I'm going to take the square root of it. When I do that, I get x plus 3 is equal to plus or minus the square root of 8. And then we subtract 3 from both sides. Okay? We go from here. So I'm not going to work it just like this one, but I'm still going to get the same answer. Now this should look familiar. This is going to look like what we get on quadratic formula. Okay? So this is telling you all the things that we're going to do. So here we go. Let's do it ourselves. So first, move c to the other side. So I'm going to subtract 3. So I get x squared plus 4x, and I'm going to leave a space, is equal to negative 3. Because the way I do it is I stick it in right there. Now the next thing we're going to do is we're going to state what b is. B is 4. Okay, so half of b is 2. And then if I take that and square it, that'd be 2 squared. Okay, so that would be 4. Okay. What we're going to do now, and this is why I like to do mine, x squared plus 4x is equal to negative 3. What we're going to do now is we're going to add in this term to both sides. So here I'm going to take half of that middle term and I'm going to add it to both sides. So I'm adding 2 squared to both sides. Well, if I take 2 and square it, that means I'm adding 4. Over on this side, I'm going to leave it as a squared term. Here, I'm going to multiply it out. So 4. Okay? Then, when I do that, I am going to take this square root of both sides. No, I'm not. I'm going to factor this. I'm going to simplify this. So that's 1. I'm going to factor this. This is x plus 2 quantity squared. Because this right here is a perfect square trinomial. Okay, now what we can do is that we can take the square root of both sides. Because I have a square term, I can take the square root of both sides. Remember, if I put the radical on, I have to put a plus or a minus. So we get the square root of a square term is just x plus 2. Plus or minus, square root of 1 is 1. So now this breaks into two things. X plus, oh, wait a second. It doesn't need to yet. I'm going to subtract 2 from both sides. So I get x is equal to negative 2 plus or minus 1. Then I'll break it into negative 2 plus 1, which is negative 1. And negative 2 minus 1, which is negative 3. So my solutions, if I write it in set notation, are negative 1 and negative 3. Okay? We're going to do more. Don't worry about it. So this is the fourth way we can solve, is when we complete the square. I always say completing the square. I don't know. Complete the square, I guess, is the proper words for it. Because the person who made this work, she's amazing as a teacher. Okay, so here we go. Move C to the other side. Subtract 1. Get x squared minus 8x is equal to negative 1. I'm going to take a different color just so that I see. What I like to do is take, okay, so B is negative 8. So half of that is negative 4. And then that would be negative 4 squared. So this is negative 4 squared. And you know what? We can just put that on both sides. Nah, we can multiply it out. So negative 4 squared is 16. That's what we add in. If I haven't already, you might want to do this in 2 colors so you can see what you're sticking in. So what we're doing is we're manipulating the equation to complete the square. So that's the whole point of this. We're going to manipulate it so it completes the square. So now we get that we can factor this side. Again, this is a perfect square trinomial because this is a perfect square, this is a perfect square, and this is square root of this times the square root of this times 2. So we're going to factor this. So we take the square root of the first one and the square root of the last one. And that's the reason I like to leave it this way. I like to leave it not squared so I know that my negative comes down here. If I leave it right like that, a negative 4. And on this side we have 15. Now notice we have a square term. If I have a square term on one side, I can take the square root of both sides. So I'm going to do that. I'm going to take the square root of both sides. When I put a radical on, what must I put on? That's right. I need to put a plus or a minus on. Okay? So now when I take the square root of it, I just get x minus 4. And 15 is not a perfect square. There's no perfect squares in it, so it stays as plus or minus square root 15. Now from here is where I like to do my next step, just because what I know is coming as far as in Algebra 2 and pre-calc. So I like to move it over here. And I get x is equal to 4 plus or minus the square root of 15. Now you'll get a point in your career, in math career, that you'll just leave it like that. But for now, we're going to write it as 2 separate ones. So for my answer, since it can't be simplified, I'm just going to write 4 plus square root 15, 4 minus square root 15. Those are my 2 answers. Okay, that's a square root 15. Okay, questions? Good. I would like it if you were in the classroom, I'd have you pause the video right now, fill in this information, and see if you can do the first couple steps. So I'm going to do the first couple steps. You try it too. If you get lost, guess what? It's all in detail right over here. Okay? So keep that in mind. Pause. Okay, so we added 2 to both sides because we have to move that constant over. B is 6. Half of that is 3, so that'd be 3 squared. So I'm going to add 3 squared to both sides. This side I'm going to just leave it as 3 squared. This side I'm going to multiply it out. Okay? Now I'm going to take and factor this. It's a perfect square trinomial, so I do the shortcut. So this is going to be x plus 3 quantity squared is equal to 11. Okay, and again, at any point, if you want to, pause yours, see if you're getting the same thing I am. Now I'm going to take the square root of both sides. When I put the radical on, I must put a plus or a minus. So we get x plus 3, because that's if I ever take the square root of a square term, it just wipes it out, plus or minus 11. Sorry, plus or minus square root 11. So now we just subtract 3 from both sides. So we get x is equal to negative 3 plus or minus the square root of 11. Now that's how I would prefer that you write the answer, because that's exact. I'm guessing the answer key is going to have it as a decimal. So let's split them. Negative 3 plus square root 11 and negative 3 minus square root 11. And let's see what those are equal to when we pull out our calculators. Okay, so pull out our calculators. And we're going to clear it, negative 3 plus square root 11. If you didn't see me do that one, I'll do it on the next one. And we get 0.31. We're going to go with hundredths place. So 0.32 is what it rounds to. Okay. So let me show you how I entered that. And you can see the last one. So I go negative 3 down here, negative 3 minus second function, x squared. I get a radical, 11. When I hit enter, notice that it gives me negative square root 11 minus 3. Hit your toggle button, this awesome button right down here. It toggles it to a decimal. So yeah, it gives me negative 6.32. Negative 6.32. Okay, number 4. I would love it if you would try this one on your own. I would suggest you pause and at least do the beginning steps. Write down, move the C, and so pause if you haven't already. Hopefully you got to this point. Now we're gonna, if you want to pause again, I would suggest that. Pause it and try it again on your own. What we're gonna do here is we're gonna factor that, so that becomes x plus 2 quantity squared is equal to 7. Once I have a square term, I can take the square root of both sides, putting a plus or a minus on the number. So x plus 2 is equal to plus or minus the square root of 7. Subtract 2, and we get x is equal to negative 2 plus or minus square root 7. Okay, then you can find the decimal for that. Number 5, just one more. So again, I would recommend pausing yours, trying the whole thing, and then come back in. So I'm going to start it. Hopefully you got it to this point. But hopefully you didn't make the mistake I did. That should just be an x, not an x squared. Okay, so now we're going to take the square root of both sides, putting the plus or minus on the number. Oh, look, we have a perfect square. Yay. So we have x plus 5 is equal to plus or minus 2. This one we get to actually come up with numbers on. That doesn't usually happen on these, does it? X is equal to negative 5 plus or minus 2. So that gives us negative 5 plus 2, negative 5 minus 2. So we get negative 3 and negative 7 as our two terms, our two solutions. Okay. Now the other thing that we use complete the square for, which is actually, I think, more beneficial. Okay, let's be totally honest here. If I have to choose, I'm not going to use complete the square in order to solve an equation. But some people like it, and so keep going with it. Not a problem, especially when a is not 1. Oh my gosh, what a pain. So the other thing we use it for is we complete the square to write the function. I don't know where function begin with an S. Write the function in vertex form. Okay, now this is useful. If I have an equation in standard form, I'm going to write it in vertex form. So I'm just going to go back over to this little worksheet, and I'm just going to pull some equations off of here. So for instance, I have the equation x squared plus 4x plus 3 is equal to 0. What I'm going to do is I'm going to rewrite it as a function. As a function, this would be y is equal to x squared plus 4x plus 3. And I'm going to take this is in standard form, I'm going to take this and make it into vertex form. Now I'm going to kind of do some weird things with it, but the reason for that is because it will actually make it easier. So I'm going to start the same way. I'm going to move the constant over with 3. Just don't worry about it. It's just going to hang out over there. Y minus 3 is equal to x squared plus 4x. Okay? Now what I'm going to do is the same thing we've been doing. I am going to take half of 4. half of 4 is 2, and I'm going to square it, because remember that's what so b is 4, I take half of b over 2 is 2, and I'm going to square it. Well, whatever I do to one side, I have to do to the other side, so I'm going to add 4 to this side. I didn't leave room. And I'm going to add 4 here. When I do that, I get y plus 1 is equal to, and I'm going to factor this, because that's a perfect square trinomial, so I combine my like terms here, factor here, x plus 2 quantity squared. So now I'm going to get it into vertex form. To get it into vertex, I have to y on one side, everything else on the other, so I'm going to subtract 1, and when I subtract 1, I get y is equal to x plus 2 quantity squared minus 1. What is my vertex? It is opposite. So -2, -1. That's my vertex, okay? So if I am ever given something in standard form, I can just use -b over 2a to find my x coordinate, plug it in, find my y, or I can complete the square and get it in vertex form, okay? So vertex form might be helpful. Let's do one more, at least for now, and then we'll look at some other ones. We'll try to find some other examples. So I'm going to start off with the equation. Y is equal to x squared plus 10x plus 21. Okay, there it is in standard form. First thing I do is I move the constant, like we always did with complete the square. I'm going to move the constant. So I have y minus 21 is equal to x squared plus 10x. Now I'm going to take half of the 10, that's 5. So I'm going to add 5 squared to both sides. I'm just going to cram it in here. I'm going to add 5 squared to both sides. Okay. And I get y minus 21 plus 25. Okay, and I'm going to factor this, and I get x plus 5 quantity squared. So that's y plus 4 is equal to x plus 5 quantity squared. You're always welcome to pause if going too fast. Subtract 4 so we can get it in vertex form. Y is equal to x plus 5 quantity squared minus 4. What's my vertex? -5. -4. So it's a shift from the parent function, left 5, down 4. Okay, let's maybe find one more. We're going to try one more. Y is equal to x squared minus 6x minus 16. I also wanted to do this one because we haven't had a lot of minuses. Okay, start off the same way. Move that constant to the other side. So add 16 to both sides. So we get y plus 16, leave space, equals x squared minus 3x. Well, I'm not sure where I came up with 3. Well, I do, but it should be a 6. Okay, now we take half of -6. Half of -6 is -3. So what did I add to this side? -3 squared, which is 9. So I get y plus 25 is equal to, factor this, x minus 3 quantity squared. Yes? Okay, move that 25 over. Subtract 25 so we can get it in vertex form. We have y is equal to x minus 3 quantity squared minus 25. What is my vertex? My vertex is 3, because that's always opposite, and -25. Okay, now that I find is helpful. Solving by completing the square, I don't do unless they tell me I have to. Getting it into vertex form, I do use that. Okay, let's look at our homework now. On this worksheet, let's complete the square, and I'm going to find one where I'm going to have you rewrite it as a standard form. So looking at your homework, I want you to try to do some of these, and I will let your teacher decide exactly which ones you're going to do. I would like you to do, though, number 8 and number 9, where you write it in vertex form. So we're going to start with y equals the equation, y equals the equation, and then write it in vertex form. So I'm going to change those to x's also, so that's what vertex form is usually going to be in. These are going to be x's. Okay, so I would encourage you to try those. Check with your teacher as far as which ones that you need to do. Okay, thank you so much. And if you have a question, let me know. This is a great one to learn, kind of complicated, but it's really, really, really helpful when you want to get it into vertex form. And I just want to show you all the different ways. Okay, if you have questions, you know where to find us. Thank you so much.